My name is Umair Hassan. I am a Iota graduate and I am going to discuss or share with you some of the key concepts from first year chapter number 1 maths for anti-test preparation. Now this discussion is a general discussion in which important things as far as anti-test is concerned will be discussed. Set of natural numbers is a set with elements 1, 2, 3, 4 till infinity. Then we have got a set of integers represented by z, in which we have 0, all the negative as well as all the positive numbers. The set of rational numbers, that is represented by q, has numbers of the form a over b, where a and b belongs to z. Now z is a set of integers and b cannot be 0. Obviously b is in the denominator. If b will be 0, that will be undefined. This is one of important MCQ. Set of real numbers is a union of q, which is set of rational numbers, and q prime, the set of irrational numbers. Now what type of questions are asked from the numbers? They used to ask set of real number is a union of which two sets of numbers. So q and q union q prime will be the answer. The next important thing is rational numbers and irrational numbers. I have discussed that numbers can be written in the form of p over q. Now they are rational numbers. Now this form p over q mean you have 16. Now as you know that we can write 16 as 16 divided by 1. Now this is p 16, this is in place of p, and 1 is in place of q. Then we have got 4. I am coming towards this decimal part. First of all, let me discuss the whole numbers. 4. Now we can write 4 as 4 by 1. Now 4 by 1 is 4. So this is p and this is q. So that means numbers in fractions. Numbers in fractions are rational numbers like 3.7. Now 3.7 can be written as 37 by 10. So 37 by 10 is a fraction, that is a rational number. Now I am coming towards the number of decimal numbers. Suppose we have got one digit after this decimal point in 3.7. Now when you have limited number of digits after the decimal, when you have limited number of digits, finite number of digits, that is also a rational number. Whereas irrational numbers are those numbers which cannot be put into the form p over q. For example, the numbers under root 2, under root 3, they are irrational numbers. Now consider the example of a number pi. Now pi is an irrational number and pi is 3.142 dot and dot. Now one thing, 3.142, and this dot means that your numbers are not terminating. So when your numbers are not terminating, mean they are continue, which is represented by this dots, and your numbers are also non-recurring, which means your numbers after the decimal point are not the same. They are not repeating again and again. This is 1, this is 4, this is 2. The next number will be a different one. So non-terminating means they are continue, and non-recurring mean number after the decimal are not repeating. That is the case of irrational numbers. If you have finite number of digits, so that is a rational number. If you have infinite digits but the digits after the decimal must not repeat, so that is an irrational number. What about the example when the number after the decimal will repeat themselves? So that is the case of rational. I am discussing them over here. Terminating decimal. Terminating or terminate mean to end. Terminating decimal mean we have got decimal point over here and we have got 2 digits after the decimal. Now they are terminating, they are finite. We have got 1, 2, 3, 4, 5, 6, 7 digits after the decimal. They are terminating, that is they are finite. We have got 1, 2, 3, 4, 5, 6, 7, 8 digits after the decimal. No, they are terminating. All the terminating decimals are example of rational numbers. What about recurring? Recurring mean an event that happens again and again, that repeats itself. Take an example of 2 by 3, 0.6666666 continue. Now they are continued, but they are same numbers that are repeating again and again. Now when a same number is being repeated, like 6 is being repeated, or even a set of number, suppose, let me give another example, 2.32, 3232323232. Suppose a set of numbers. Now this is a set of 32, 32, 32, 32. Now when a set of number repeats itself or a single digit repeats itself and it is continued, mean they are infinite. Now that is an example of rational numbers. So terminating ones are also rational, recurring ones are also rational. What is a non-terminating and non-recurring decimal? A non-terminating mean that is not going to terminate, that is mean it is infinite, and non-recurring mean that is not going to repeat again. So a non-terminating and a non-recurring is one which neither terminates nor it is recurring, and that is an example of irrational number. Take example of this one, 3.141592654. The first point is that your numbers are not repeating, they are different. Second thing is that they are continued, so they are non-terminating. Dot shows non-terminating, and from these digits you can say that they are non-recurring, the digits after the decimal. So that is an important irrational number, and that is called pi, which denotes, and what is pi? Basically pi is the ratio of circumference of any circle to length of its diameter. So in the entry test, questions are asked from the concept of terminating, recurring, and non-terminating, non-recurring, mean from rational and irrational numbers. So if you have the knowledge of the basics of these, you can attempt them. The other topics in this chapter are properties of real numbers, what is binary relation, then properties of real numbers, that include Clojur's law of addition, associative law of addition, additive identity, additive inverse. Then we have got multiplication laws of real numbers. For real numbers, Clojur's law of multiplication, associative law of multiplication for multiplication, multiplicative identity, multiplicative inverse, commutative law. These are important topics or things you need to prepare from chapter number 1. We have properties of equality, then we have got concept of complex numbers, that is numbers of the form x plus iota y, where x and y they are real, while iota is square root minus 1. Now they are complex numbers, where x is the real part, x is the real part, and y is called the imaginary part of complex numbers. Like 3 plus 4 iota, we have 3 as real part and 4 as imaginary part. Now these are important things that are part of anti-test preparation. They ask questions from powers of iota to solve questions from power of iota. We have to do questions related to operation on complex number, addition, subtraction, multiplication of complex numbers. Then we have to represent complex number as ordered pair of real numbers. We have properties of the fundamental operations on complex numbers. We have 5 to 6 properties, and then the real plane or the coordinate plane, another important thing that is being asked in the anti-test. Then the concept of modulus of a complex number, concept of abscissa, concept of ordinate, geometrical representation of complex number, what is Argand diagram. Now the imaginary axis, basically y-axis in Argand diagram represents imaginary numbers. Then we have got theorems on complex numbers and what is polar form of a complex number. Now in this video I have discussed the start of chapter number 1, few concepts, and the rest of the topics that we are going to have in our anti-test preparation. So if you want to prepare yourself for an anti-test, you can register or you can contact us by commenting in the comment box. Thank you so much.